does this smart valve have a pilot?
Yes.
Where is the pilot located?
On this tube. In here somewhere.
So it's inside the sealed burner compartment.
That's, yep.
Why is that called a sealed burner compartment?
Because it's sealed and it's where the burners are.
Cool, eh? So finally, a word description that matches the physical condition.
Yeah.
Tell me all the parts you would expect to see inside if you remove that cover.
There would be a pilot.
Okay, so a pilot burner.
Pilot burner. There would be some kind of ignition, which looks like it's probably an HSI maybe? Because I don't see any spark.
Okay, so what makes you think it's an HSI? Give me 7 reasons.
7?
Okay, fine, I'll go easy on you. Give me 6.5.
6.5. I don't see.
Do you want me to help you?
Sure.
Okay, it's a Honeywell smart valve. So you know that a Honeywell smart valve uses an HSI. That's number 1.
Okay.
Number 2, do you see 2 blue wires going into the burner area?
Yes. and
What do you
it
think
says-
they're going for?
Well, it says ignition where they're.
Okay, so it's going to the HSI. So the 2 blue wires are going to the HSI. What voltage is the gas valve?
24.
What voltage is the HSI?
24.
Do you see another black wire going into the burner area?
Yep.
What do you think that's for?
Probably like a flame sensor.
Thank you. So you got 2 blue, first off, you know it's a Honeywell smart valve, so you know you got a pilot. And you know that you've got an HSI and a flame sensor. You got 3 wires going into the burner area. If it's spark ignition, you'd only need max 2.
Maybe more.
If it's integral, you'd only need 1,
Right.
correct?
Yes.
So based on that, 3 wires going in, this is part of the process where I say, look at something, know what it is. As soon as you see a Honeywell valve, 2 plugs on the top, you know it's a smart valve. You know it's 24 volts. You know it's a 24 volt HSI. You know the 2 blue wires are generally going to be going in for the HSI. You know you got a single black wire going in, flame sensor. You know you got a sealed burner compartment. You got a pilot burner in here. Give me the process for igniting in the top side. I want to get my main burner going. What's the process?
It probably.
Don't talk about thermostat, okay? Only talk about the Honeywell smart valve.
Okay. The HSI will heat up. and
Let's go back 3 steps. 4
Probably-
steps, maybe 5 steps.
Like, you mean like the vent motor start?
Nope, I only want to know about the Honeywell smart valve.
It self checks.
Thank you, self-check. So what do I have to do to make it, or encourage it to self-check?
What do you have to do?
Yeah,
Um,
what'd you say?
That's what needs to be energized.
Exactly, you gotta give it how many volts?
24.
So you give the gas valve 24 volts. Now you can do the smart check,
Right.
or the self-check, sorry. You can't do a self-check if you don't have voltage, right?
Right.
So it does the self-check, everything says good. What does it do next?
And then,
You can say, I'll help you out a little bit. Energize 2 small coils,
2 small.
1 relays,
yeah,
2 sets of contacts closed.
right.
What do those 2 contacts do?
Probably the HSI and the pilot valve.
Thank you. So HSI gets energized, pilot valve opens. What happens next?
The HSI will heat up and then light the pilot,
Correct?
and then the flame will be sensed,
Correct?
and then that'll open up the main.
No.
No?
You're gonna say something?
No.
No, you're not gonna say anything?
Sorry, I can't do this statement.
Anybody wanna help them?
Flame.
I agree, the flame
yeah.
sensor does sense the flame. I agree
The
something happens
HSI
next.
will shut off.
Thank you, the
Yeah.
HSI shuts off.
Okay.
And why do I dwell on that? Why do I bring that up? Because you're smart. You know that if I'm looking in here, I see the pilot flame, I see a pilot flame, I see the HSI glowing. What do you suspect the problem is if it doesn't progress any further in the sequence?
Of not sensing the flame.
Thank you, it's not sensing the flame. If it doesn't sense the flame, it won't shut off the HSI. It'll go for the trial for ignition. What's the trial for ignition, please?
90 seconds maybe?
Thank you, it's a 90-second trial for ignition. So it'll go for the 90 seconds, then it's gonna shut off. Someone else might think, oh darn, it must be the main gas valve. Main gas valve didn't fire. Must be defective main gas valve. No, sorry, bud. It tried for 90 seconds, it didn't see the flame, it didn't sense the flame, it shut down. Continuing on,
So the HSI will shut off?
correct? So the relay de-energizes, the contact opens, HSI shuts off.
Yeah. And then the main valve,
Now you can energize another relay,
and then that will open up the main valve.
contact closes,
Right,
energizes,
the main valve,
gas flows.
and then it will ignite
Thank
the
you.
main burners. Yes.
What else happens?
Like in here, you mean? Like,
Well, with the Honeywell Smart Valve, the process,
oh. After the main burners fire?
yeah, after the main burner fires. Okay, let's go back,
Does the
Pilot
pilot?
valve,
let's go back 6 months. You were January intake?
yeah.
Yeah.
Okay, so let's go back 6 months. Blue furnace. On the other side of the wall. After the main burner fires, what's the next step in the process?
I'm confused what you're, like, are you asking?
No, let's go back to that.
Okay, the blower would come on, right?
Thank you, the
Yeah.
blower comes on. What starts the blower?
The, temperature sensor,
Yeah, what do we call that thing?
the
FL?
fan, is it limit? No.
Fan limit
Yeah.
switch. Okay, the fan limit switch starts the main blower. Everybody agrees? Good, because you're correct when you say that. You know what I'm thinking? That's great on a blue furnace. The fan limit switch starts the main blower. What starts the blower here?
Oh, is it the smart valve? Is it the
Keep
delay?
going.
There's a time delay?
And not quite. There is a time delay, but it's not in the smart valve.
That's on the control.
So how does the something else starts it, but how does it know to start it? Let's go back to the Lennox G20. What caused the main blower to start? Was it a fan limit switch on the G20?
No.
What was it?
It was in. Well, then it sent a signal to say that there was like flame, and then it started. Right?
Thank you, but not quite. On the Lennox G20, it's not quite as smart, is it? On the Lennox G20, as soon as the ignition controller energizes the pilot valve, remember that orange wire I told you about? It goes from the ignition controller, the orange wire energizes the pilot valve, and then it continues on to the board below on the Lennox G20. When that orange wire gets the signal, it says, okay, somebody upstairs is trying to get the main burner going, I'm just gonna start timing. So it times for 45 seconds, then it starts the main blower. So that orange wire starts the main blower. Do you see an orange wire here?
Yeah.
Oh man, coincidence?
No.
Where does that orange wire go?
It looks like it goes down to the board.
Beauty, eh?
To here.
So it goes to the board below. And what does it do down there? Starts a timing sequence for the fan on delay. So on this one, when the main burner fires, it sends a signal down. On the Lennox G20, when the pilot valve energized, it sent the signal down. And 45 seconds later, the fan started. On this one here, can you get on your knees, please? Look at the circuit board, look at the lower left, and what do you see?
Lower left. The little switches?
Yes, what do we call those switches?
Oh, what do they call it?
DIP,
Yeah, dip switch.
dip switch, stands for dual inline package. Okay, so the dip switch. How many switches are on the dip switch combination there?
There's 3.
There's 3. Can I give you a hint?
Yeah.
2 of those dip switches are for fan off delay.
Right.
If 2 of them are for the fan off delay, how many possible timings are there for fan off?
2?
Say 4, please.
4.
Thank you. Because 2 switches could be up, that gives me 1 time. 2 switches could be down, that gives me another time.
Yes.
Or crisscrossed, another time, and flip the other way, another time. So there's 4 fan off delays. What do you think the other dip switch is for?
Fan on.
Thank you. It's the fan on delay. So I can set this for 30 or 60 seconds for the fan on delay. Clear? So that is important in the sequence. So once I get that signal down there, we're good. So let's do a little troubleshooting.
Okay.
Thermostat calls for heat. Inducer starts. Nothing else happens. No click, no pilot attempt, main burner doesn't start, main blower doesn't start. The only thing that happens is the inducer starts.
Right.
Can you give me 6 possible reasons?
So pressure switch,
Pressure switch, good.
the tubing,
Yep, tubing, good.
blocked vent.
Which vent? Okay, I like that one.
Yeah.
Next, is there a second vent on this one?
There's an air intake.
Yeah, there's an air intake, so it could be blocked exhaust or a blocked intake. Either one's gonna cause the same symptom, isn't it?
Yes.
You said a problem with the tubing.
Yes.
You said
The pressure switch itself.
the pressure switch could be defective.
The wiring, maybe a wire came out.
Wire, so we're up to 5 now.
Or just insufficient power, like blowing. like
Insufficient negative pressure.
Yeah.
Okay, keep going, give me one more now.
Um,
Let's think for a second. When the pressure switch closes, where does the signal from the closed pressure switch go?
down to the board.
No, wait, I haven't finished asking the question yet.
Okay.
When the pressure switch closes, where does the signal from the pressure switch go? And don't say to the board below.
We go to the gas valve.
Thank you, it goes to the gas valve. Okay? Follow it.
So like these wires here.
Yeah, you can follow it.
Blue ones.
And one of the blue ones goes loops and it comes up here to
Right.
this one.
In here, yeah.
Okay, so now you're kind of thinking, shit, maybe Steve does know what he's talking about, right?
Yeah.
Now you're not thinking that. You already knew it.
Yeah, that's right.
Okay, so here's what happens. The blue wire goes to the gas valve, so can you give me one more reason why nothing else happened?
It could be the gas valve.
Thank you. Gas valve picked up on a defect and said, no, I'm not going any further. And there's no LEDs on here to tell you that. Fair enough? So you see how it's important to know the sequence of operation and how every component works. Okay, here's another question for you. You're doing so well.
Okay.
We get the main burner going. It runs for about 3 minutes and then the flame goes out. But nothing else happened. The inducer started. We ended up getting the main burner going. It ran for about 3 minutes and then the flame went out. Nothing else happened.
The blower.
Okay, so the blower didn't come on. Thank you. Give me 7 reasons why the blower didn't come on.
Oh. Is that capacitor for the blower, I'm assuming?
Okay, defective capacitor, good one.
Okay. Maybe the board is screwed up. not
Okay, the
being
board's screwed up.
Yeah.
Another good one. So a defective relay in the board or it didn't get energized.
Yeah.
Continue, that's
It
2
could
so
be
far.
the blower itself.
Yep, go on. Give me 2 possible faults on the blower.
On the blower,
Yep.
it could, I guess, like burnt out like windings.
Okay, so seized or open windings.
Yeah.
Okay, so it could be seized
Okay.
or open windings.
Okay.
Give me some more.
There could be, if there was a loose wire or something with the valve, like when it's self-checking, you notice that? For the, like.
No, it won't pick up on that.
So it could be that.
Well, it could be a loose wire or wire's not on the right terminal
Right.
or it came off. Okay? Give me one more. It has to do with the orange wire.
Is the valve defect? Could be a
Thank
valve
you.
defect.
Defective valve. It didn't send a signal on the orange wire to tell the board to start timing. See how simple it is to troubleshoot?
Yep.
When you know what you're talking about. And it's important to know what you're talking about. I can't stress that enough. If you don't know, look at how Look how complicated the sequence of operation is. It's not simple. But as soon as you know the components, you know how they're gonna interact together. As soon as you see a Honeywell Smart Valve, you're thinking, oh yeah, that orange wire energizes the board to start the timing for 30 or 60 seconds. After 30 to 60 seconds, the motor should start. If it doesn't start, hey, it could be the signal never made it to the board. Could be defective relay in the board. Could be defective board. Could be loose wire. Could be defective capacitor. Could be a seized motor. Could be open windings on the motor. Now, some people say, Steve, why are you going into all these details? Yeah, you're right. Maybe I go into too much detail. Right? So let's look at the other approach. Main burner came on. The flame came on, but the motor didn't start. So the simple approach is something's wrong. So you're the tech and you go to the customer, something's wrong, the main blower didn't start. Yeah, that's great, but that didn't make it any further down the progress to solve the issue, did it? That's why you gotta know all the intimate steps in the sequence. You gotta know where to look. Is it the board? Is it the orange wire coming down there? Is it the gas valve? Capacitor? Seized? Open winding? Loose wire? You gotta be able to troubleshoot and figure out for sure which one it is. You wanna change the right part, maybe you gotta change the gas valve. Maybe it's just a bad wire. Maybe you just change the capacitor. Maybe you gotta change the motor. But you're gonna feel like an idiot if you change the motor. You tell the customer, oh, I changed the motor because I thought it was the motor, but it didn't fix the problem. I'm gonna try and change something else. Then you change the circuit board. I'm gonna try something else. Then you change the gas valve. So now you're up to about $1,000 in parts. The customer's saying, is it working yet? No, not yet. I'll get there soon. There's only about 10 more parts I gotta check. Okay? But if you know how to...
This happens to be the wire, right?
Yeah, and then you figure out, oh darn, the wire's not on. Somebody must have taken the wire off or they didn't put it on properly. Okay, now here's another question for you. I said earlier to you, a blocked secondary heat exchanger. So we were talking about defects that would cause it not to proceed on the sequence of operation. So we said a blocked vent, blocked intake. We said defective pressure switch, problem with the hose connection, inducer's not running, inducer's not creating sufficient negative pressure. Any of those items could cause it, couldn't it? Okay, so it's not going to progress on the sequence of operation. We also know that, hey, the valve could have got 24 volt, but it just said, I'm screwed up, I'm not going to work. I did myself check, something's not right. So you know that there's several steps there. Now let's give a little bit of thought to the process here. We said earlier, or I asked the question earlier, or it came up about a blocked secondary heat exchanger. First off, what type of furnaces have secondary heat exchangers? Mid or high efficiencies? Sorry? I'll pretend I didn't hear that. High efficiencies, right? So why do we need a secondary heat exchanger on high efficiency?
To make it more efficient.
Thank you. Incredible, because I was thinking that myself. Okay? As a joke answer. Not as a serious answer. No, okay, but you are right. To make it more energy efficient, you need a secondary heat exchanger. What happens in the secondary heat exchanger? Okay, so air from the house will pass over the secondary heat exchanger. What happens inside the secondary heat exchanger?
Heats up the air.
No, inside. Outside, it heats up the air. Inside the secondary heat exchanger, what happens? What's going through the secondary heat exchanger? Inside it.
Flue gas?
Flue gases. So what happens to the flue gases?
Condense?
They condense. And what happens when you condense?
You get water?
And you get extra energy out of the flue gases, right? Because as I'm changing from steam or humidity into water, I get extra energy out of it. So that's how it turns into a high efficiency. Now, what does the secondary heat exchanger look like? Have you ever seen one? Can you look at the top here?
Looks like tubes.
It looks like an air conditioning coil, doesn't
It
it?
does.
Little bit unusual shape to it.
Yeah.
So, let's look at this one. This furnace over here is, well, here's a question for you. You're up. Give me 4 reasons why you know that this is a high efficiency furnace.
Just like plastic piping,
Okay, plastic vent material, that's a good one. Next,
secondary heat exchanger,
it's got a secondary heat exchanger, good. What's this thing over here?
condensate,
Condensate trap, good work. What's this material here made of?
plastic,
So, a plastic inducer assembly. 4 reasons you know it's high efficiency. So let me tell you something. This item right here is a heat exchanger of a similar furnace. This is the secondary heat exchanger. So what happens is, this side right here is where the inducer fits. So if you look at this black plastic section, you look at this one over here, there's the black plastic section. The inducer motor sits right on here and it sucks. Okay? And while it's sucking, it blows the exhaust out. So let me show you this. This is a typical inducer assembly out of here. So you see the triangular shape here? That lines up with this. So when this goes out there, it sucks. Where's the pressure switch attached on this one? You can have a look at it.
Like this big square.
Yeah, that square tube, which fits onto this. Now, depending on the model, it can fit on different spots, okay? So, it's sensing the negative pressure thanks to the inducer. So when this sits on here and it runs, it sucks. It makes a negative pressure. What does this pressure switch respond to? Negative pressure. And it causes the contact to close. So once the contact closes, the appliance thinks, good, let's get going. It's time to go. We're going to start the sequence of operation. Fair enough? Now, if I've got a block secondary heat exchanger, will the pressure switch see negative pressure?
You said yes earlier.
Yeah, it will. It's still going to see negative pressure. So the pressure switch says, yeah, I'm seeing negative pressure. I don't care that it's a block secondary heat exchanger. The inducer's running, it's sucking, it's negative pressure. Let's get the show on the road. So what happens? It fires the appliance. The flame comes on. The problem is, the flame is not being sucked into the burner area. It's not being sucked through the primary and then through the secondary because it's a block secondary heat exchanger. So what do you think happens?
Roll out.
Flame rollout. Thank goodness we got a flame rollout. So if you come to this appliance, it's a flame rollout trip. Think about a block secondary heat exchanger. It's quite possible. Now, I know you're super smart. Although weren't you using a hammer earlier?
possibly, yes.
No, I don't think it was you. You're way too smart for that. So here's what's up. We've got a block secondary heat exchanger. We have a flame rollout. How are you gonna know if it's a block secondary heat exchanger? Yeah, we had the flame rollout, but how do you know it's not because it's overfiring or there's something else going on? How are you gonna know it's a block secondary heat exchanger? That's okay, you don't have to know the answer yet. When I put it on the test, I want to know the answer then. So what's the answer gonna be when you're doing the test? I'll give you 5 possibilities.
Okay,
Is that fair?
I think so.
Yeah, I'm just gonna tell you. See, take the stress off you.
I was ready.
Okay.
I was ready for it.
But here, I'm gonna ask you this question. On this hot water tank, what did I tell you is the typical negative pressure you're gonna see in the hose?
Oh,
What's the range? And I told you it's the same for a mid-efficiency furnace with an inducer. You wanna help them?
I think 0.3 then. Small.
Sorry? I'm trying to think. Well, whether you wanna help them or not.
No. It's
Okay.
like 0.2, 0.3 like that. Something small.
Well, 0.7 is probably mid, but it's 0.5 to -1.
Yeah.
So that's the range. So -0.5 to -1. Not super negative. You guys, when you're sucking on a straw, are probably doing that, depending on what you're sucking on. If it's one of those McDonald's thick shakes, you're probably sucking a little bit harder. Okay, and that's because on a mid-efficiency appliance or in this hot water tank, the heat exchanger section is wide open. It's really easy to suck the flue gases through. On this one here though, look at it. I got my inducer right here. It's gotta suck through the primary heat exchanger, through the burners, pull through there, then the outlet for the heat exchanger up here loops and goes in here. So look at the torturous path. I gotta suck all those flue gases through this before it comes here. So it takes a bit of sucking to do that. So the net result is this. You get your digital manometer, and you guys will do this later, hook up to the hose over here. You're gonna see that it's gonna suck -2 to -3 inches water column. So it's more than it is on a mid-efficiency. So it's sucking harder. If the heat exchanger is blocked, what do you think is gonna happen to that pressure? Is it gonna go more negative or less negative? It's gonna go more negative, isn't it? So if you hook up to this appliance and you see that it's sucking -3.5 or -4, what are you thinking? Yeah, but why is it sucking too hard? Because it's a blocked secondary heat exchanger. So if you get a flame rollout, check with your digital manometer, check the pressure that the inducer is doing. If you see it sucking to -3.5 to -4, it's a blocked secondary heat exchanger. That's why the flame rollout's tripped.
And then what do you do?
Put a new secondary heat exchanger in or change the furnace. And I'll give you a hint. Carrier had a lawsuit, and Carrier, in their infinite wisdom, without admitting liability or fault, settled the suit. They will give you a new heat exchanger. They will give you new primary heat exchangers. They will give you a bunch of gaskets and a bunch of parts, and they'll pay you $250 to cover your labor to change out the heat exchanger. In my opinion, you tell the customer, yes, I can get you a free heat exchanger. Yes, they have a small labor allowance. Yes, it's gonna cost you an additional $1,000 to $1,500. Why? There's 2 or 3 parts that aren't covered for free, and it's not an easy job. I've done it twice in my life. I will never do it again. Never. If somebody comes to me and I tell them it's a block secondary heat exchanger, and they say, Steve, what should I do? I want to put in a new furnace. And the customer says, Steve, you're giving me a hard time. Why? I know it's a free secondary heat exchanger. I know they have a $250 allowance to help to offset the cost. To which you reply, yeah, they might have $250 allowance, but it's going to cost you another $1,500 on top of that. And I can put in a new appliance for $4,000. So why do you want to spend $1,500 on a 15-year-old furnace, spend an extra $25 and you've got a new one? Oh, by the way, the new one comes with a 10-year parts warranty, and the new one's less likely to have trouble, and if you have a single service call on the old one, you're going to wish you put the new one in. Because if you have to change this inducer because it fails, or the gas valve because it fails, you're looking at another $1,000. One trip out to diagnose it, then you gotta go pick up the part, you gotta return with the part, you gotta put it in and start up the system. So the bottom line, don't bother, just put a new furnace in. Both times when I've done it, I've regretted it. So, be smart, learn from my mistakes. Because one of them, I changed it, it was for my cousin. She said, oh Steve, please just do it. I said, no, I think we should put a new furnace in. No, please just do it. Okay, fine. So I do it. She's my cousin, so I only charge her $1,300 instead of $1,500. Net result, the inducer went like 2 months later or 3 months later. And it was one of the modulating inducers. They're about $700 my cost. At that point, you've already spent the $1,300 on it. Bite the bullet and put the other one in. The thing is too, changing a heat exchanger on this one, has anyone ever had open heart surgery? Okay, it's worse than open heart surgery, okay? They'll change your heart out or fix it in like 2 hours. If I'm doing it, heat exchanger here, you're looking at 8 to 10 hours. Why? Every single screw. Okay? Every single screw has to come apart when you're changing it. There's not a single screw you can leave together. Because I thought, like an idiot, just undo all the screws on the back side and get it out. Oh, wait a minute. On the one I was working on, I had to cut the venting, so I couldn't get the venting out. It was a tight space. I had to cut the vent. I had to cut the intake pipe. I had to put new couplings on it when I put that together. I had to undo the gas line. That was a pain. I had to take all the electrical out because the other one had an electrical box here. You can't slide this out with the electrical box. I think, man, is this ever a pain? Then I go to pull it out, it still won't come. Oh darn, 2 screws from the bottom side are coming up into it. And I look at, oh darn, I can't get at it. It was slightly different than this one. I had to take the whole circuit board out to get at it. And then I get that circuit board out. Oh man, there's 2 more screws back behind the blower. I had to take the blower out too.
Basically took out the entire furnace.
Yeah, so there's not, and without a word of a lie, there was not a single screw left in. Every single screw has to come apart to change it. Then you gotta put it all back together again and line it up. So, that was the last one I did. I will never do one again. Here's what's up too. Somebody else had a fault with one of them. I told them we're gonna put a new furnace in. They said okay, do it. Within 4 hours, their furnace was out, the new one was installed. It took me 10 hours to change the heat exchanger. I changed the entire furnace in 4 hours. I came up, diagnosed it. I phoned one of my guys. I said, grab a furnace and come on up here. We gotta change the furnace. He went to the supplier, grabbed the furnace, got up to the job site. I'm at the job site, I got the original one out. He brings the new one in, we install it. I had to make those little transition pieces that I'm training you guys to make. We make the little transitions, done. In 4 hours, the new furnace is up and running.
Done it in 2.
Sorry?
I've done it in 2 when everything fits.
Yeah.
So everything's identical.
Good. Why do you always have to be better than me? Just because you're a week or 2 younger. Okay? Because I'm 35 and he's like 34 in 11 months. He looks 34, doesn't he?
Yeah.
I thought so. He looks young. Well, he stays in shape because he still plays hockey all the time. He's busy enjoying life while I'm busy making money. I don't know who's better. Okay, bottom line, a few more questions for you before we part company today. Next, you said this was a sealed burner box, didn't you?
Yep.
Thank you for that. Step back over here, please. Now, a sealed burner box, what does that mean? It means this area is sealed. I've got to bring a pipe over here. The pipe's going to bring my combustion air in. When my combustion air comes in, it gets burned, mixed with the gas, it burns in the primary heat exchanger, passes into the secondary heat exchanger and condenses, comes out the pipe here, 120 degree flue gas temperature, give or take. Got a question for you though. I'm looking at this. Why are there two hoses on the pressure switch? Can you give me any legitimate reason for that?
To make sure that there is
Pressure
difference.
differential?
Okay, a pressure differential.
between,
So it's sensing a pressure differential.
right,
Which pressure has to be more negative? The burner box or the inducer?
probably the inducer.
You're correct. If I block the intake, what happens to the pressures?
Would it increase, or, I mean, like decrease the,
So,
They get more
you
negative.
use the right words, correct, they'll get more
Yeah.
negative if I block the intake. I agree totally.
yeah,
And I lose the differential.
Right.
Because the negative pressure here will get closer to the negative pressure here, I don't have sufficient differential. If I block the exhaust, what happens to the pressure? More negative or more positive?
more positive?
Yep, it's gonna get more positive. So it'll get closer to zero.
Right.
If I have a blocked secondary heat exchanger, what happens to the pressure?
More negative.
This would get more negative,
Correct.
and then I guess nothing really would be happening up here.
Well, this won't get as negative as it
Yeah.
was before.
Right,
They're not sucking enough through.
Flame roll out?
Yeah, and you'll get the flame rollout. So here's the thing,
but this one closed if that was happening.
it's still gonna close. So do I have a flame rollout on this one?
I, yeah,
Can you point to it?
this little,
Okay, it's got one flame rollout over here. How many flame rollouts does this one have? Can you have a look at it?
Time's up, Steve, for it's like the other class.
Yeah, I'll let them wait for a few minutes. I wanna finish with this. They're nice guys, they don't mind waiting.
Just thought.
Did you say two?
Yeah.
Okay, so this one has two because it's a more open burner assembly. If I rotate left, right, up, down, I want it to trip. This one only needs one because it's a sealed burner box. If there's a flame rollout in here, this is gonna pick up on it. Okay, so we're clear on that. Next question is this. Why do I have a hose going from the sealed burner box back to the gas valve? What's that hose for? Any ideas? Is that a good fair question that I asked?
is it, like the, is it vent?
Okay. Vent thing.
What do you call it? Like a leak,
Vent limiting orifice.
yes.
Okay. Look at this one. Does it have it over here?
The hose, you mean?
Yeah.
No.
From the gas valve.
No.
It doesn't. This one does have a hose from the gas valve to the sealed burner box. Why does it have that?
Because it's a sealed box, burner box,
Keep going.
so. it
So
can
why do
have,
I need that hose?
I'm not sure.
Not as much gas flow in
Sorry?
there? So there's not as much gas flow?
Exactly. And why would there be possibly too much gas?
Because it's sealed.
Because it's sealed. Go on.
Sealed.
Okay, you're up. Why can I possibly have too much gas?
Oh, if it fails to ignite?
No. Because that'll only do that for how long on this one?
Oh, well, it's pilot, so.
Yeah, so 90 seconds, right? On this one?
Probably like 3.
3 seconds. Okay? So why do I, because there's potentially negative environment here. If this is negative, because I've got a long intake pipe, I could have negative 1 inch here. If I've got negative 1 inch, and my manifold pressure is normally what pressure? What's a normal manifold pressure for a furnace? 3.5, right? So normal manifold pressure is 3.5. If it's going into an area here, which is negative 1 inch, what's my differential? 4.5. One's positive 3.5, one's negative 1. The net differential 4.5, it's going to overfire. If it overfires, now I've got a new set of problems, right? It could go off on the flame rollout, it could go off on the high limit, but that's due to overfiring versus a block secondary heat exchanger. So with that in mind, that hose going back to here, it goes to the back side of the regulator on the gas valve. So if I've got it set for 3.5 with the cover off, and then I put the cover on, and it goes to -1, that hose will suck back on the back end of the diaphragm, overcome a little bit of the spring pressure, automatically resets the manifold pressure to 2.5. Now I got my 3.5 differential between manifold and the burner environment. Remind me next week, we're gonna hook up a digital manometer on here, we're gonna fire it, I'm gonna block the intake, we'll watch the manifold pressure change.
Like we did with that,
Sorry?
when we did that water well, we also did the pressure, the whenever. Right?
Say that one more time?
I'm saying when we